Good morning. My name is Noureddine Ouelhaci, and I am here today to talk to you about composite design pattern, also known as object tree, and how you can implement this in your term project. Composite is a structural design pattern that lets you compose objects into tree structures and then work with these structures as if they were individual objects. In other words, composite compose objects into tree structures that represent whole part hierarchies. Composite lets clients treat individual objects and compositions of objects uniformly. A leaf has the same interface as a node. The intent of the composite pattern is to compose objects into tree-like structures to represent part or hierarchies. The hierarchy are the composites, while the individuals are the leaves. Let's study this example to understand more about composite design pattern. Imagine you run Amazon's delivery system, and for the sake of this example, suppose you have two types of objects: order boxes and products. Now, a box can contain several products as well as a number of smaller boxes, and these little boxes can also hold some products or even smaller boxes, and so on. Okay, our delivery system is supposed to calculate the total price of all the products contained within the mother box, but how are we going to do that? Well, we could try to unwrap all the boxes, go over all the products, then calculate the total. And while this would be doable in the real world, in a program, it won't always be as straightforward as writing a for loop. I actually went ahead and tried to come up with the most concise solution for our current problem. And to do that, I used recursion, as you can see in front of you. If you run it in a small main and provide it with any input given the classes we have, you will see that the solution works. However, on top of not really being ideal in terms of the inputs we are providing and the attributes we are storing, the problem with such solutions is that they may not be always available for us to pick. You see, what if we wanted to add a packaging cost on each box, for example? We will need to open this particular method where all of our logic is stored and added. Or for example, what if more product types were introduced with more complex pricing mechanisms? In this example, we only have one product class. Or what if more boxes or more items were to be added into the mother box? The whole logic we wrote will have to be revisited. All of these make the generic approach too hard to come up with, and sometimes impossible because you have to know many other details beforehand. The solution to these problems resides in applying the composite design pattern. The composite you see using the composite pattern makes sense only when the model and object structures of our application can be represented as a tree. And if you take a look at our previous representation of this example, you will see that. Well, it really is very similar to a tree structure. So to apply this pattern, what we are going to do is create a composite box class whose sole purpose is to store multiple other boxes. Then let this class and the different product classes, which in this example will be the book and video game classes. Let's say implement the same interface, This interface, which is the box interface, will declare a method for calculating the total price. Now, in our product classes, this method's implementation will simply return the product's price, but for a composite box, it will iterate over each item in the box, ask its price, and then return a total sum for this box. If one of these items is a smaller box, that box would also start going over its contents until the prices of all of its inner components are calculated. A box could even add some extra cost to its individual price, such as a packaging cost. The greatest benefit of this approach is that you don't need to care about the concrete classes of objects that compose the tree. You can treat them all the same way by making use of the common interface. When you call a method, the objects themselves pass the request down the tree. Okay, with this example in mind, let's take a look at the structure or class diagram of the composite design pattern. The first thing you may have noticed is the component interface, which was represented by the box interface. In our example, this interface describes operations that are common to both the simple and complex elements of the tree. The next classes you can see are the leaf and composite classes, which were respectively represented by composite box and different product classes we made use of. Leaves are basic elements of the tree that do not have sub-elements. Usually, leaf components end up doing most of the real work since they don't have anyone to delegate the work to. On the other hand, the composites, aka the container, is an element that has sub-elements, leaves, or other containers. A composite doesn't know the concrete class of its children. It works with all sub-elements only via the component interface. Now, on to the last piece of this diagram, which is the client. The client works with all elements through the common interface we created, which means that he can work in the same way with both complex and primitive objects of the tree. In this example, the composite pattern lets you implement stacking of geometric shapes in a graphical editor. If you want to learn more, please check the source file provided in this presentation. The composite design pattern is applicable when there is a need to show part-whole hierarchy of objects, as well as when you want to treat all of these objects uniformly. So, how to implement composite pattern? First, make sure that the core model of your app can be represented as a tree structure. Try to break it down into simple elements and containers. Remember that containers must be able to contain both simple elements and other containers. After that, declare the component interface with a list of methods that make sense for both simple and complex components. Next, create a leaf class to represent simple elements. A program may have multiple different leaf classes. And before the final step, create a container class to represent complex elements. In this class, provide an array field for storing references to sub-elements. The array must be able to store both leaves and containers, so make sure it is declared with the component interface type. Finally, define the methods for adding and removal of child elements in the container. When it comes to programming language, you can work with complex tree structures more conveniently. Use polymorphism and recursion to your advantage. In program open-closed principle, you can introduce new elements types into the app without breaking the existing code, which now works with the object tree. Algorithm is a little different. It may be difficult to provide a common interface for classes whose functionality differs too much. In certain scenarios, you had need to overgeneralize the component interface, making it harder to comprehend. There is a very important relationship between composite and decorator pattern. Composite and decorator have similar structure diagrams since both rely on recursive composition to organize an open-ended number of objects. A decorator is like a composite but only has one child component. Decorator adds additional responsibilities to the wrapped object, while composite just sums up its children's results. You can use decorator to extend the behavior of a specific object in the composite tree. Applying both pattern lets you clone complex structures instead of reconstructing them from scratch. So to sum everything up, the composite pattern helps you create a tree-like object structure using simple and complex objects to dot both of these elements. We'll have to implement the same interface, and by making use of this interface, the client will be able to treat individual objects and their compositions uniformly. Additionally, by making use of this pattern, you will be applying the open close principle because you can now introduce new element types or products, in our case, into the app without breaking the existing code. Want to know more? Please visit these websites. Thank you for being a great audience.